from VTT and Tom is from VTT, so our presentation is a little bit more technical, maybe, but hope that's not a problem. So I will show you some examples of the automation projects we have done, and then something a little bit different what we are currently doing. First example is automatic control system of a road grader, and the second is automatic control system of a stabilizing cutter. I don't know if you are familiar with stabilizing cutter, but you will hear more about it when Anna-Kaisa is speaking. Then something about our current activities. Tommy will tell you about wireless communication technologies in road construction, and I will present you one example how it could be used in asphalt paving process control. Maybe you show, Rauno showed one slide of this, but I can explain it a little bit more detail. This control system is based on solving the inverse kinematics of the road grader, and this means that the blade of the grader can be controlled in Cartesian coordinate system. And so this means that you can make very easy manual control to it. There is only one joystick, and if the user wants to raise the blade, he just pulls the joystick back. Or if he wants to move the blade to the right, he just pulls the joystick to the right. And computer controls individual hydraulic cylinders. And also we can use positioning and 3D model of the road and control the blade automatically. And this control system is based on using only one PC computer, Windows NT, and real-time extension in time for control software. And there is a graphical user interface and functions for quality measurement and documentation of the work. And we have measured accuracy, and it's about plus minus 20 millimeters. And it's measured from the surface of the road, which is done with this system. And increase in productivity it doubles the productivity of the grader. And also the workload of the operator is much easier, and no staking is needed. And we started this project with simulations. We wanted to test in simulation environment and show how it should work. And then we built 2 prototypes, and the second prototype has been in use since 2001, and I think it's still in use, and about 800 working hours per year is how much it is used. Then this stabilizing cutter. This machine is a whole new design, and it's designed and built by Fundament Oy. And it's a machine used in road rehabilitation and reinforcement of old road structures. And it weighs about 45 tons, and it's 8 meters long. It's very big machine. And for this machine, we developed a control system that makes the control of the machine very easy. So there is an automatic height and slope control, and also these control parameters can be put to a file, and the machine reads the file, and thus in the file there is parameters what to do in a certain location on the road, and it controls the stabilizing agent mixture. So this machine sprays hot bitumen or mixes it to the material. Also because this is very big machine and it's used in very narrow roads, there is a computer-controlled four-wheel steering, and there are different operating modes. And how we implemented it. There is a big box where all the electrical equipment of this machine are, and at the corner of this big box there is a PC 104 computer with real-time Linux, and this little computer does all the real-time control tasks. And for user interface there is a Windows PC, and these are connected to each other by standard Ethernet link. And the user can see everything what's happening in the screen, and control is really easy. Basically, the user watches what's happening and drives the machine, and almost everything happens automatically. So if, for example, if user raises the cutting mill, the system takes that into account and changes the stabilizing agent mixture automatically. And these benefits of this are better work quality and reduced material loss. And for nowadays, bitumen is very expensive material, so this is very important. And this is one of our current activities. We have two projects where we are developing and using wireless links in construction. And one thing we are currently studying is asphalt paving process control. And main goals of this is synchronization of asphalt mass production, transportation, and asphalt spreading. And we are trying to put sensors to these machines and get information from the process, and then try to collect this information to a one process view that shows key parameters of the process. What are the waiting times of the trucks, when the next truck is coming to the paver, when trucks are coming to the asphalt plant, and etc. And also this allows automatic documentation of the work. So every truckload we know where it goes on the road. And we are trying to do this as automatically as possible. We have tested also in one project to use some mobile phones and truck loaders to things using phones, but in this project we are trying to do this more automatically. And what we have machine models. These are quite simple models that measure process values and detect events and then send data to the server. And server collects this data, stores it, and forms the visual view. And we have mobile applications, different workers or work supervisor can see what's happening on the field. That is what we are trying to do. And my colleague Tommi Parkkila will tell you something about technologies we are going to use.